Assalamualaikum. I'm from Group Assignment Project 5. So for a project, we choose the topic which is design and development of buck converter. So this is our report. So for the introduction, I will pass to Mohamad FAIZ to explain.
Okay, my name is MOHD bin HAIRANI. So our group choose to do the project about of buck converter. So for the introduction, the lead acid batteries are the most commonly used as energy storage, emergency power backup, motor start, vehicle lighting, as well as generator starting because of their low cost and simplicity of accessibility regardless of low energy density. In off-network PV application, compared to a lithium-ion battery, a lead-acid battery has less advantage cost, proportion, and clear net present value. That's why we use our project for this title. So next, for the design planning. So this is our simulation from the MATLAB for the circuit design. Okay, this is our result for the simulation. So for the first graph is input voltage versus time. For the second graph is input current versus time. For the third graph is output voltage versus time. And the fourth graph is output current versus time. Next, for our design calculation, the V in we use is 12 volt, V out equal to 3.6 volt, frequency equal to 20 kHz, and V limit equal to 20 millivolt, and I equal to 0.8 ampere. So for the solution, number 1 for the duty cycle is 0.3. For the number 2 filter inductance is 157.5 microH. For the third filter capacitor is 250 microfarad. For the fourth minimum inductance is 192.5 microH. And for the lastly is minimum capacitance is 0.7 microfarad. Okay, next for the methodology, this is our circuit for the buck converter. So the switch shown above circuit will typically be a power electronic switch like MOSFET, IGBT, and BJT. The switch will be switched, turned on or off by utilizing a PWM signal. The buck converter's process is somewhat similar to PWM dimming. We all knew the light were being decreased by a PWM signal. A short duty cycle means that the average voltage seen by the load is small and the average voltage is also elevated as the duty cycle is increased. So I will pass to Muhammad Zakwan.
Okay, Assalamualaikum. My name is Muhammad ZAKWAN Muhammad ZUBAIDI. I will explain about a design planning of buck converter. This is a flowchart of buck converter design. First, start and then design criterion. We in 12 watt, we out 3.6 watt. And then component selection, such as voltage source, MOSFET, diode, and others. And then inductor, capacitance, and diode selection based on calculation. Then simulation of buck converter in Simulink. Then monitoring the pulse generator. After that, output voltage under 3.8 volt. If no, we will do some troubleshoot the problem. If yes, analysis and discuss result, and then the end. Then I will explain about buck converter operation principle. This is our block diagram of buck converter. The buck converter is a step-down converter that lower the high peak voltage to the low voltage required. The schematic diagram of the buck converter shown in figure 4 has an inductor, a capacitance, and two switching elements. This is MOSFET and diode. This project has an input voltage of 12 watt and output voltage of 3.6 watt. The block operation scheme of the buck converter shown in figure 3. This figure is show the basic buck converter schematic diagram. The other figure is show the switch is on, and the last figure is the show the switch is off. After that, I will explain about buck converter duty cycle. The ratio of output voltage to input voltage can be adjusted by varying the duty cycle of switch. The longer the switch is turned on, the greater output voltage will be. The duty cycle of switch is usually called the converter duty cycle. If the switch and the adapter are lossless, input voltage is converted to output voltage with no loss of power and the conversion is 100% efficient. For instance, a 60% duty cycle mean the power is off 60% of the time and off 40% of the time. While a 50 duty cycle mean is power is on 50% of the time and off 50% of the time. That's all. I will pass to my friend.
Right, so my name is HANI, HILMI. So I will explain about the result and discussion. So for the result, this is our result from the simulation of the Simulink. It's first shown this input voltage this time. This is the current input current is 11 H. For resistance, we use the 11 ohm voltage limit. We use the 20 millivolt. Voltage output, we use the 3.6 volt capacitor 250 microfarad, and for the current 0.8 ampere. For the frequency 20 kHz, and for the pulse width, we use the 30%. This is our volume of simulation in MATLAB. So for education is for certain application, controlling the DC portion of a pulse output may be enough, but often the target is to generate an output that is strictly DC. One way to get the output is to insert a low-pass filter after the turn. A low-pass inductor capacitor LC filter is connected to the simple converter. Once the switch is open, the diode provides a direction for the inductor current and is reverse biased when the switch is closed. As the output voltage is less than the input, this circuit is called a buck converter or down converter. Buck converter advantage are line voltage variation has large tolerance and cost and size are lower. The buck converter is very simple and it requires only one power switch. The efficiency of buck regulator is about 90%. The disadvantage of buck converter are slow transition response and high output ripple. Normally, input filter is required for the buck converter. So, for the conclusion from the project, we conclude that the result of the experiment may be accepted. The student used the buck converter as the project buck circuit as the project and design in Simulink or MATLAB for the simulation. If the result is positive one, suggest the for the minimal data and suggest the continuous circuit mode. Everything is quickly calculated from the calculation. So this is our weekly previous minute meeting. So I will show the simulation. So this is our simulation. So if we run, we will get the result as this. This is for the input voltage this time, input current this time, output voltage this time, and output current this time. So this is our measurement, this is our time, and this is our volume. So that's all from us. Thank you.